In the last episode of this series, I asked a question about the arch on the inside of the foot. Do we want this arch to be high, low, or somewhere in the middle? Some of you may have answered high. This is an idea that is largely a reaction to not wanting to have flat feet. When you excessively raise your arch, you're bending the foot and making the foot shorter. This is not the optimal way to use the foot for weight bearing or movement. There is another answer that is widely out there that says, yes, of course, the arch should not be excessively high, but we don't want it to be low either. We want it high, but not too high. This answer is also incorrect. We want the arch on the inside of the foot to be low, as that is what will lengthen and widen the foot. Really, this arch is more accurately described as a truss. A truss is a variant of an arch, where a tie rod at the base prevents the separation of the two beams that create the arch shape. When a load presses down on the apex of a truss, the tie rod at the base prevents collapse. In your foot, the tie rod is the plantar aponeurosis, which is the major fascia on the sole of the foot. In order to stretch that fascia and make it taut, we need to lengthen the foot, which means lowering the apex of the arch. We'll explore the specifics of this in just a moment, but I'm sure some of you are thinking, come on now, you're not telling me I want flat feet. And no, I'm not advising anything that will cause flat feet. The fascia at the bottom of the foot will only stretch so far, and as it's made taut, it will prevent collapse of the foot. You cannot collapse the foot through lengthening, unless you tear the foot apart. If we look at images of people with flat feet, you will see that they always have their feet pointed outwards, often quite severely so. The big toe is usually in line with the inside of the heel in a noticeably peculiar way. I have not found a single example of flat feet where the outsides of the feet point straight ahead. This is because, as I just said, it's impossible to flatten the foot through lengthening. You will lower the arch, but you will not flatten the foot to the floor. Flat feet are a problem that is only possible when you turn the feet outward. Today, we're going to look at this book, Sarrafian's Anatomy of the Foot and Ankle. It's a somewhat unique book in that it's an exhaustive look at the anatomy of the foot and ankle, put together by one doctor with an enormous interest in the foot and ankle. Though without a doubt, his work was built on the work of the many important figures in the field, whom he references frequently. It's a highly detailed and thoughtful book that is certainly among the best and most definitive on the subject. It's used by doctors and practicing surgeons, and it's a great piece of science. It's not an easy book to read. It has many technical terms that make certain passages virtually unreadable for most people. I'm going to pull out one paragraph that captures the important findings of the functional anatomy section. But first, I'd like to give the definition of the foot that we find in this book, because I think it's quite exquisite. The foot is a flexible, multi-segmented system convertible through compression, torque, and instant remodeling into a rigid structure capable of bearing weight and of acting as an efficient lever arm for the purpose of propulsion. What this says is that the foot is a flexible thing that can be changed into a rigid structure capable of bearing weight and propelling the body. The foot changes through compression, which is another way to say it flattens under the load of a weight or by pressure, through torque, which is a rotational force, and through instant remodeling, which refers to the way that the bones of the foot can change how they're configured and to a certain degree change the shape of the foot. There's something very important here. If we want our foot to work optimally for bearing weight or moving the body, so that's standing and walking, we want the foot to be a rigid structure. Rigidity is often seen as a bad word when it comes to posture, and there are types of rigidity that we don't want. But in general, we need rigidity. Rigidity is just an inability to be bent or forced out of shape. Most people suffer from a lack of rigidity. They are pulled out of shape. For our fascia to be stretched and taut, we need rigid bony structures that will not be pulled into shortening by the pull of the fascia. With the feet specifically, we can look at how prosthetic feet are made. They are very rigid, and that allows even a person who has lost their foot to have a spring in their step. We want to make our foot rigid like steel, as a relaxed foot will make propulsion more difficult and inefficient. Let's get to our paragraph from Sarrafian now. I'm going to break it down sentence by sentence so we can all understand what he's saying. What he's describing is the close pack position of the foot and ankle. What that is and why it's relevant will be explained by the end of the paragraph. In the standing, weight-bearing position on even ground, the internal rotation of the tibiotalar unit induces instant remodeling of the foot plate. The tibiotalar unit is a specific way of saying the ankle joint. It's the joining of the tibia and the talus. Internally rotating the tibiotalar unit means rotating the ankle inward in this plane. This will cause the inner malleolus to go back and the outer malleolus to go forward. The talus is internally rotated, adducted, flexed, and supinated. He's describing movements in 3 planes here. For our purposes, we can note that while we want the talus to be internally rotated, we don't want to collapse onto the inside of the foot. The internal rotation is in this plane, while the supination is in this plane. Flexed means in dorsiflexion as opposed to plantar flexion. The talar body is in its lower position relative to the calcaneus, and the talar lateral process, forming a solid male V wedge, is in close contact with the corresponding female V contour of the calcaneus laterally, at the junction of the sinus tarsi and the posterior calcaneal surface. This is a description of the instant remodeling of the bones. His point in this sentence is that when you manipulate the tibiotalar unit in this way, you are making it so that the calcaneus and talus have the most bone-on-bone contact. He describes the lateral process of the talus being like a V-shaped wedge that fits into the V-shaped contour of the calcaneus. This is another concept that can be applied more broadly. To improve our posture, we don't just want to lengthen the fascia and muscles. We also want the joints to have maximum congruity between the surfaces of the bones. That is what is efficient for weight bearing and preventing uneven wear and tear. The talar head compresses medially into the acetabulum pedis, which offers an increased capacity of volume. The head of the talus presses down into the socket that connects the foot to the leg. The calcaneus is in exorotation, pronation, valgus, and eversion. This means the heel is widened away from the center, with the weight on the inside, not the outside. The navicular and the cuboid are also in pronation, whereas the forefoot is in supination twist to maintain the plantigrade posture. The navicular and the cuboid are the next bones past the talus. They are pronated, that is, rotated in towards the center, while the forefoot should be supinated, that is, rotated away from the center. The inferior calcaneonavicular ligament and the supramedial calcaneonavicular ligament are under tension. The subtalar cervical ligament and the calcaneotalar interosseous ligament of the canalis tarsi are also under tension. Here he is saying that all the major ligaments are under tension, that is, taut and not slack. In this position, the talus is in a synarthrodial position at the talocalcaneonavicular joint and is in the close pack position. What we've described so far is the close pack position of the foot and ankle. To understand what he means by synarthrodial position, we can read this passage from earlier in the chapter. To understand it, though, we need to know what a synarthrosis is. A synarthrosis is a joint which allows no movement under normal conditions. The joints between the bones of your skull are an example. In 1945, McAnally presented and demonstrated anatomically and functionally the fundamental concept of the synarthrodial posture of synovial joints. In this posture, the synovial joints function as if they were synarthroses. In the synarthrodial position, the joint surfaces are maximally congruent, the chief ligaments are tense, and the joint is screwed home. The synovial joint is the most common kind of joint. The joints of the feet are synovial joints, and obviously they can be moved fairly easily. But McAnally demonstrated that when these joints are put into a specific posture, the joints become synarthrodial, which means they are extremely rigid and do not allow for deformation, like the joints between the bones of your skull. The joint surfaces, which means the surfaces of the bones, are maximally congruent, and the chief ligaments are tense. This synarthrodial posture is also called the close-packed posture or close-packed position of the joint. With the combination of exorotation or valgus of the hindfoot and supination of the forefoot, the lamina pedis is untwisted. This combination of movements untwists the foot. As demonstrated by Lewis, in this position, the short plantar calcaneal cuboid ligament is also under tension because of its oblique disposition. Another ligament made tense. The foot now has a lower medial longitudinal arch and is longer and wider. The medial longitudinal arch is the arch on the inside of the foot. In the close pack position, this arch is lowered, and the foot itself becomes longer and wider. The lowering of the medial longitudinal arch further tenses the plantar ligaments and the plantar aponeurosis. The lowering of the apex of the truss causes the tie rod at the bottom of the foot, the fascia, to be made taut. The foot is now less flexible, more rigid, and converted to a more efficient lever arm. When the foot is in the close pack position, it is less flexible, more rigid, and is a more efficient lever arm. We're using the foot as a lever arm when we walk. That is how we propel ourselves. So to make it as efficient to use as possible, we need the foot to be rigid and also maximally lengthened and widened, which occurs when it's in the close pack position. This brings us back to why I have recommended Jando Masuero's position of the feet. It is no coincidence that Masuero's recommendation for screwing the ankle matches with the description of the close pack position. He is of course advising us to use the close pack position and creating directions that we can use to bring the lower leg into the close pack position. So why do we want the arch on the inside of the foot to be low? Because that is what will lengthen and widen the foot, stretch the fascia at the bottom of the foot, and remodel the foot into a rigid lever arm that we can use efficiently. I know this is a lot of information, so we'll come back to this next episode, but I'll leave the full paragraph from Sarrafian in the description and in a pinned comment, so you can read through the whole thing now and understand what it says. Questions and comments are very much welcome in the comments section below. Join me next episode and we'll dig a little deeper into this.